Good morning, Logic 1. I hope you guys are doing well on this supposed to be rainy day. So today we're going to be doing lesson 96, which is estimating angle measures and using the distributive property with algebraic terms. So by now we have learned how to use a protractor. We are going to learn how to estimate an angle measure based on a common everyday household item like a clock. So the clock is a full circle, as you know, and a full circle is 360 degrees. Our clock is divided into 12 numbered sections that mark the hour, from one numbered section to the other. So from 12 o'clock to 1 o'clock. So this piece, this piece right here represents 1/12 of a full circle. Well, 1/12 of a full circle, we would write that as 1/12 of a full circle, which would be times 360 over 1, is going to be 30 degrees. So when you do the math, it's 30 degrees. So
do red, Mom.
Sure, I'll do red. Sorry, my mic is on my lap here with me. So each rotation from 1 hour to the next is going to represent a 30-degree increase. So from 12 to 1, this piece right here is 30. So from 12 to 2 would be 30 degrees plus 30 degrees, which is 60 degrees. And then from 12 to 3 would be 3 groups of 30,
Mom?
which 3 times 30 is 90 degrees. So if we were to do then even down to the minute, there are 60 minutes in an hour. So we would take 360 degrees, which is the measurement of the circle, and we would divide it by 60 so that each little teeny hatch mark represents one little angle. When you do the math, you get 6 degrees. So from 12 to 12:01 is 6 degrees of an increase. So here we have we've drawn an angle on the face of a clock. The vertex of the angle is at the center of the clock. One side of the angle is set at 12 and the other set is set at 8 minutes after. Well, we know that each minute that goes by represents 6-degree increase. So we can then multiply 8 times 6, which is going to give us 48 degrees. So from 12 to 12:08, it's going to be, or 8 minutes after, it's going to be 48 degrees. So let's go ahead and do example 1. We're going to estimate the measure of angle BOC in the figure below. We read the angle as B, this ray right here, O is the vertex, and C. So we're going to go ahead and look at that and kind of look at our clock and estimate. I look at this and see almost like a 90 degrees, so maybe a little bit less than 90 degrees. I want you then to use your protractor to find the measure of angle BOC. And then by how many degrees did your estimate differ from your measurement? So go ahead and pause right now, do this example before you flip to the next page. And I want you guys to write your answers here before we go to the next page. All right, sorry, I went too far. Okay. Did I go too far? Okay, here we go. Sorry about that. Okay, so so here's a solution. We use the mental image of a clock face with angle BOC. So BOC being right here, BOC, we lined up the C above the 12 so that it's a straight ray. And then we put the ray of B, or BO, between 12 and 3, or 2 and 3, I apologize. So we know that each increment is 6 degrees, right? So this is about 12 minutes right here. So 12 times 6 is going to be 72 degrees. So we estimate that the measurement of angle 72, or BOC, is 72 degrees. So when you do it on the paper and you can trace BOC on a paper and extend the side, so we use a protractor, you'll find that the measurement of BOC extends through halfway between 70 degrees and 80 degrees. And so it really is 75 degrees. And so we find out. So my measure, I overestimated this. And I was off by 15 degrees. So it just depends on what you estimated. These guys estimated 72 degrees, is off by 3 degrees. Okay, so let's go ahead and kind of switch over to doing some algebra here. So we are going to talk about the distributive property. The distributive property teaches that whenever you have a quantity on the inside that is a sum, sorry, that's supposed to be a plus, not a 4. We're just going to start all over with this one. So let's say I have a quantity A times the sum B plus C. We can rewrite this as A times B plus A times C. There are going to be times that we do not know the values of the variables, and so we have to rely on the rules of distributive property to help us simplify the problem. So if I had the problem like 2 times the sum of 7 and 1, I know that we can do this math first because these are known quantities. So 7 plus 1 is 8, and we can do 2 times 8, which is 16. But let's say I didn't know what this quantity was. Let's say this was A. Well, I can't add 7 and A, but I can use the distributive property to simplify. 2 times 7 plus 2 times A. Now we have simplified 14 plus 2A. So let's go back over to your math right here. So let's go ahead and do this example right here. We have 2 times the difference of x minus 3. And what we're going to do here is we're going to do 2 times the difference of x and 3. And we're going to simplify 2 times x is 2x. 2 times negative 3 is going to be negative 6. So there's your first simplified algebraic expression. Let's do B, negative 2 times the sum of x and 3. Negative 2 times the sum of x and 3. So we're going to do negative 2 times x, which is negative 2x, and negative 2 times 3, which is negative 6. Now there's no more simplifying that we can do, so there's our solution. All right. And C, oh, it has it right here. C, we have negative 2 times the difference of x and 3. So we're going to multiply negative 2 times x, which is negative 2x, negative 2 times negative 3, which is positive 6. Now let's go ahead and do x times the difference of x and 3. I'm going to do it on the whiteboard over here. X times the difference of x and 3. So we have x multiplied by x, which is going to give us x squared, not 2x, minus x times 3, or negative 3 is negative 3x. All right, that's your solution. Okay, so let's go ahead and do one that's a little more difficult here. We have x squared plus 2x plus 3 times the difference of x minus 2. So let's simplify where we can. Well, we have the parentheses here, and let's do 3 times x is going to give us 3x.
We have told you.
3 times negative 2 is negative 6. So now we have an expression where we have x squared plus 2x plus 3x minus 6. Well, let's combine like terms. You have 2x and 3x that you can add, and you get 5x. So our most simplest term, or most simplest expression is x squared plus 5x minus 6. All right, what I'd like you guys to do now is to do the lesson practice, and then it goes all the way through M. Make sure that it gets checked, and then do your mixed practice. All right, guys, I'll see you guys. I guess I won't see you tomorrow, but I hope you guys just check into the YouTube page for tomorrow's lesson. Okay, hope you guys are well. We're praying for you. Bye.